Well, hello. Howdy. Yo. Screw Diaz. We're going to talk about similar figures. So, this one, what we're going to do is we're still going to apply a sequence of transformations to a pre-image and figure out what the resulting image is. Or we're going to figure out how did a pre-image become an image. But the difference here is now our figures are no longer going to be congruent. So the reason why is when we perform a dilation, that's when we become a similar figure. So a similar figure is a figure that has the same shape, the same size, the same shape, but it doesn't necessarily have the same size. So what I mean by that is it's when we do it, everything's done proportionally. So if I take like a square and I shrink it down to a little square, I'm keeping everything proportional on the side lengths, so these are the exact same shape. However, it's now just a little bit smaller. Or if we make it larger, it's the same thing. So that means it's similar when they're the exact same shape, but they're just different sizes. Congruence means that they're the same shape and size. So first, we're going to identify the sequence of transformations to get from A to B. And then we're going to tell whether or not they're similar or if they're similar or if they are congruent. So first, we know A is a lot smaller than B, so we have to perform an enlargement or a dilation. Okay, so now we got to figure out, well, what dilation what's our scale factor? What do we have to dilate by? So my side length for this left side is 2. This side length is 1, 2, 3, 4. So it's a 4 by 4 square, a 2 by 2 square. So I know my dilation I know my scale factor is 2. So I'm going to dilate by a scale factor of 2. So that's the first thing. Let's get them to be the right size. Once I perform my dilation and I get it to be the right size and I multiply everything by 2. So now to perform this dilation, I'm just going to multiply all these points by 2. So this -1, -1 is going to become -2, -2. And then I know 1, 1 is going to become 2, 2, 1, 1's 2, 2. There we go. So here's my new square once I do that dilation. Now I'm just drawing this because now I can see where I need to go from here. I want to get this point to here. So I got to translate it up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So translate up 6. 4 right, or right 4. So I dilated by a scale factor. I figured that out by knowing what my side lengths are. And so I went from 2 to 4, so I had to double it. And then I translate it to go from A to B. These two are similar. They are not congruent. They are similar because they are both squares, so they're the exact same shape. However, they are different sizes. One is a lot smaller than the other, but they're smaller or larger by a scale factor of 2. Okay, try this one on your own. See how you do. So it looks like we're going from figure C to figure D. So again, we shrank it. It looks like C to D went smaller this time instead of larger. So from here, I know I said again, but I shouldn't have said again. This is last time we enlarged. Now we're going to go smaller. So it looks like, and let's figure out how much smaller we went. Well, it looks like this side length is 1, 2, 3. This is 4. And this side length is 1, 2. So we always go new overall. So my scale factor was 1/2. So my scale factor, first thing we're going to do is we're going to dilate by a scale factor of 1/2. And that's going to shrink it quite a bit. That's going to shrink it to the correct size. And then what we gotta do is figure out, well, where do we go from there? So first, let's do that. So if I'm going in half, I'm dividing this by 2, so this is gonna become 1, 1. This one's also gonna become 1, 1. This one right here is gonna become negative 1, 1, negative 1, and this is gonna become 1, negative 1. Okay, and then when I divide this one by 2, I'm actually gonna go down to 1 half. Let's go like this. Damn. And that's me trying to trace. Not very pretty, but it'll work. So now we are the same size. Now what I have to figure out is, how do I get from here to here? So there's a few different ways I could do this, because I have to rotate it. So I could do a 180 degree rotation. That would totally work. And that would flip this around. I could reflect it across the y-axis, and that would also flip it around. And it looks like if I reflect it across the y-axis, I would then just have to translate it up. So, and if I did a rotation, I would also just have to translate it up. But I'm just going to do a reflection, because I like reflections more. To me, they're easier. Because if I reflect across the y-axis, this is all just going to flip, where this little angled side over here is now going to be on this side. So I'm going to reflect across y-axis. And then once I do that, this point's now over here. So then I just have to slide it up 1, 2, 3, 4, 5. Translate up 5. So sometimes when you do this, you're going to have to draw what you do to be able to see it. And there's nothing wrong with that. These are similar, by the way. We know they're similar because they were different sizes, and we had to do a dilation, which made it now similar, but they're still maintain the same shape. Okay. And then sometimes you're going to have to do a sequence of transformations, and they might be written algebraically, or they might tell you what they're doing. And then it says, apply each transformation to the image of the previous transformation. So we're going to have multiple images here. And then we're going to label each image with the letter of the transformation. So like for A here, so I'm taking these points. And then let's see here, this negative x, y means I'm really reflecting it across the y-axis, because that's the algebraic representation of that. And really it's just telling me to change your x's from positive to negative, or to switch the sign of it, I should say. So I'm going from 3 to negative 3. I know it's 1, 2, 3, 4. And it's a box. So here, let's make this a little bit less painful. Still not very good, but it's better. Okay, so there's A. Now, so we already got this one done. For B, rotate the square 180 degrees about the origin. So this is where, if I rotate 180 degrees, our x's and our y's stay the same. But it's just going to be up here now. So if it's going to be up here, that means instead of at negative 3, negative 4, it's going to be at positive 3, positive 4. Instead of being at negative 7, negative 4, I'm going to positive 7, positive 4. And then I know it's 1, 2, 3, 4 tall. 1, 2, 3, 4 tall. Let's see if I can draw it. Oh, yeah. Oh, yeah. There we go. Sweet. That's not bad. All right. So there's my second one. Now, let's see what it's asking us to do. It's saying to translate it, I got to subtract 5 from my x values, subtract 6 from my y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That was this point right here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I still have a side length of 1, 2, 3, 4. That's what this has been this whole time. It's been a 4 by 4 square. So I can go 1, 2, 3, 4. I know it's going to keep the same shape, right? The same exact size. So instead of just counting each time, I just kind of took a little shortcut and then drew a really ugly square. So there's C. Finally, it's asking me to shrink it down by a half. So let's do this one in orange. So it's asking me to dilate it by multiplying each point by 1/2. Well, if this is at 2, 2, so if I take half of that, it's going to be at 1, 1. And all of these are going to end up at 1, 1. No, that worked out poorly where my C ended up being inside of shape D. So here we'll do this. Bam. And then this one was, there we go. And so I started here and I ended up here. So I started with this one and I ended up here, this little one up here. All right, guys, that is all. So things to remember: similar equals same shape, different size. Congruent is same size and shape. All right, I hope this helped. Thanks for watching. If you have any questions, let me know. Credias out.